Hey everyone, welcome to the first episode of our networking concepts for cybersecurity series. Networking is the backbone of cybersecurity, and if you don't understand how data flows, you will be struggle to secure it. In this video, we will break down the basics of networking and explain everything in simple terms with real-world examples. Ready? Let's start. So, networking is the process of connecting devices which helps in sharing data and resources like files, printers, or even the internet. Without networking, the digital world as we know it wouldn't exist. Networking isn't just about computers, it involves phones, IoT devices, servers, and many more things. And networking enables collaborations, for example, employees in an office working together by sharing data to each other. You can take an example and think of a classroom where students pass notes to each other. And instead of running around, they can give their notes to a teacher. Just treat the teacher as a central device who passes them along to the right person. Networking works the same way. Devices use routers and switches to communicate efficiently in a network. Every device or a network has a unique address. Just like your home or office, this address called an IP address ensures the data you send or receive goes to the right place. Basically, IP addresses comes in two versions, IPv4 and IPv6. IPv6 is newer and necessary because we are running out of IPv4 addresses. Devices on the same network like your home Wi-Fi typically uses private IP addresses while public IP addresses connect to the internet. Just take an example of like you are ordering some pizza online. You provide your address so it gets delivered to your house. An IP address works the same way. It tells the internet where your device is located. While IP addresses can change, a device MAC, that is media access control address, is permanent and unique. It's like your fingerprint in the networking world. Every networking device, like your laptop or phone, has a MAC address embedded in its hardware. Like routers often use MAC addresses to identify and manage devices on a local network. Let's say you want to secure your home Wi-Fi. You can create a list of approved MAC addresses so only devices with those fingerprints can connect. It's like VIP list for your network. Protocols are the rules that govern how devices communicate on a network. Without protocols, devices wouldn't understand each other. You can think of that as device languages that help them communicate with each other. Some common protocols are HTTP, HTTPS, used for browsing websites. HTTPS adds a layer of encryption for security. FTP, that is file transfer protocol, allow you to upload or download files. DNS, that is domain name system, translate domain names like google.com to its corresponding IP addresses. TCP/IP, that is transmission control protocol or IP internet protocol, the backbone of the internet, ensuring data packets are sent and received correctly. You can take an example like when you visit a website, your browser uses HTTPS to securely fetch the data. Think of it as sending a log package through a trusted courier. Data doesn't travel across networks as one big chunk. It splits into smaller pieces called packets, and each packet takes its own route to the destination and is reassembled there. Packets contains headers like an envelope that specify the source, destination, and other details. This method makes network faster and more efficient as packets can take multiple paths simultaneously. Let's take an example of sending a 100-page document through the mail. Instead of sending the whole stack, you send individual pages in a separate envelope. They will arrive at the destination and are put back together, and that's the same way data transfer works using packets. The OSI, that is Open System Interconnection Model, is like a recipe that breaks down networking into 7 layers, each responsible for specific tasks. In this video, we will just take an overview of OSI model as it requires a whole video for itself to understand it completely in depth. So we will discuss this in detail in next videos. So as I already told, it contains 7 layers, starting with physical layers that handles the actual hardware like cables and switches. Second layer is data link layer that manages MAC addresses and error detection. Third layer is networking layer which helps in routing the data using IP addresses. Fourth layer is transport layer which ensures data is delivered without errors using TCP and UDP protocols. Fifth layer is session layer that ensures that a stable session is established. Sixth layer is presentation layer that handles the encoding and decoding part. And seventh and the final layer is application layer, is what you see like your browser or email client. Think of the OSI model as a factory assembly line where each layer has a specific job. Together they ensure that the product its data is delivered flawlessly. So in today's video, we explored what networking is, how devices are identified with IP and MAC addresses, the importance of protocols, the concept of packets, and an overview of OSI model. Understanding these basics is crucial for mastering cybersecurity. In the next video, we will dive deeper into the OSI model and explore common networking devices like routers, switches, bridges, hub, and firewalls. If you are excited to learn more, hit the like button, subscribe, and let me know your thoughts in comments below. See you next time.